Hello, I'm Carly McAvoy. Today we're looking at quadratic equations. I'm going to do solve by completing the square. And complete the square means that you add or subtract something, but you always are adding something, a number to get a trinomial square. So if I have a trinomial square, that means I have something that when I factor it, I get the same thing twice. A trinomial square is what you get when you square a binomial. So this is an example of a trinomial square. So what would you add to make this a trinomial square? If I had this and I wanted to add a number here so that it would factor this way, well, the simple formula is b over 2 squared. What is b here? It's -8. And it doesn't really matter because we're going to square it whether we include the negative. But if I take -8 and divide by 2 and then square it, I get -4 squared. And that gives me 16. So if I add 16 here, then I could factor that. What would it factor to? Well, here's a nice little trick. Whatever you had inside the parentheses before you squared is what's going to be here. So what I'm going to get is y minus 4 squared. That would be the factored form of that. I didn't ask you to do that, but that's just what would happen. What would you add here? Well, to figure that out, I would just take 20, divide by 2, and then square that, because 20 is my b. b is the coefficient of the x term, or that first degree term. And so then I get 10 to the second power, which is 100. So I would add 100. What would that look like if I was to factor it? Well, I don't have to do any factoring. I know whatever comes here is what's going to be here. So that's going to be x plus 10. So completing the square is adding something so that when you add that on, you get a perfect square trinomial. I don't know why I wrote subtract, but people make mistakes. Okay, what if you have an odd number like 5? Well, I can still do this. I have 5 over 2 and then square it. I'm going to get 25 fourths. Well, 25 fourths starts to sound a little scary, but when we know if we want to factor that, we only have to look to what was in the parentheses before we squared it. And so I know that this would factor to x plus 5 halves squared. And that's all I have to do to get there. Okay, so let's solve a couple of equations with that idea in mind. When you want to complete the square, you want to make sure that your a is 1. A is the coefficient of the x squared term, right, or the second degree term. We always want to make sure that that's 1. So here's 2 examples where it is 1. We're ready to go. That says 30 sloppily. So this doesn't factor. So what I want to do first is I want to move this 30 to the other side. And I'm leaving a spot because remember, I want to complete the square by adding. And so I'm going to move this over, and now that becomes positive 30 by adding. And now if I take -10, divide by 2, and then square it, that's going to tell me what to add here. That's going to be -5 squared, or 25. But if I add 25 to this side of the equation, I need to add 25 to the other side of the equation. I have to do the same thing on both sides for this to work. So adding 25 to both sides keeps everything in balance. And then I'm going to go x, and I have -5 in there. So -5 squared, and then equals 55. If I take the square root of both sides, now I've completed the square. I can use that square root property that we learned before, and I get x minus 5 equals the square root of 55, or x minus 5 equals negative square root of 55. And that gives me x equals 5 plus or minus the square root of 55. All right. What about this one? If I move the 17 to the other side, I get -17. And then I'm going to take my 4, divide by 2, and square that. And that gives me 4. So I'm going to add 4 to both sides. Then I'm going to factor this. No thought process needed. I know that's going to be x plus 2 squared. -17 and 4 is -13. Now I'm going to take the square root of both sides. Now I'm just completing this problem by using the square root property. And I have x plus 2 equals, well, remember I have a positive and a negative here, just like I did over here. But the square root of 13 would be fine, but with the negative in there, I have to write I square root of 13, or x plus 2 equals negative I square root of 13. And when I solve that, I get x equals negative 2 plus or minus I square root of 13. Remember, you can write those two things separately if you'd like, or if you're called upon to do so, but a plus minus suggests two different solutions right there. Okay, two more. Remember I said A had to be 1 if you want to use the complete the square method. So in this problem, what I'd have to do first is divide everything by 2, and that would give me x squared minus 7x. And I'm going to go ahead and swing that to the other side and get 3/2. So then I can complete the square. Unfortunately, I've got an odd number here. And if I take negative 7, divide by 2, and then square it, I'm going to get 49/4 that I'm adding to both sides. And then I'm going to factor this, but I know that it's going to factor having a negative 7/2 in there, because that's a nice shortcut to know. And then I'm going to have 3/2 plus 49/4. And you're welcome to use your calculator to do that, or you could do it on in your head. I can see that 2 times 2 would be 4, and 3 times 2 would be 6. So that's 6/4, and 6 plus 49 is 55/4. And now I'm going to take the square root of both sides, and that's going to give me x minus 7/2 equals, and I'm just going to write it in one place this time, plus or minus the square root of 55/2. Now if I bring that 7/2 to the other side, that's going to become positive. So I have 7/2 plus or minus the square root of 55/2, and these have the same denominator, so frequently you'll see this answer as 7 plus or minus the square root of 55/2. So that would be a nice way to write that answer. We could also separate them out and say 7 plus the square root of 55/2 and 7 minus square root of 55/2. That would be a way of separating those if we're not allowed to use the plus minus. So number 4, we do have a 1 here, so we're set to go. P squared plus 5p is equal to 3 when I move that 3 to the other side. And then I have 5/2 squared, which is 25/4, which I'm going to add 25/4 to this side to keep a balance. Notice I'm not doing one add and one subtract. I want to do the same thing on both sides so it's balanced. And then I have p plus 5/2 squared. And then I have 37/4. Is that right? I think it is. You can do that on your calculator to check. And then we take the square root of both sides. And I get p plus 5/2 equals plus or minus square root of 37/2. Because the square root of 4 is 2 down there. And then I get p. And I'm going to do this all in one step because this is going to become negative 5 plus or minus square root of 37/2. So I did in one step what I did in 2 steps over here, but I could see they have a common denominator of 2, so I just went ahead and combined my numerators to get this. And you're welcome to take that intermediate step in the middle, if you need it. Okay, have a fantastic day.